Hello friends, welcome to bispsolutions.com. My name is Sumit and I'm a subject matter expert with Python. This is my another video in Python machine learning, and the topic for today's video is k nearest neighbor in Python. In other language we can call it as KNN or k nearest neighbors. So let's try to understand what exactly KNN is and how can we implement KNN algorithm in Python. So KNN, it can be used for both classification and regression predictive problems, and it is widely used in classification problems in the industry, and it is a type of a supervised machine learning, and it is also known as, or we people used to say that it is one of the simplest of all machine learning algorithm, and it is fair all across all parameters of consideration, and it is commonly used for its easy of interpretation and low calculation time to perform calculations, to perform KNN algorithm. And it is nothing, it simply calculates the distance of a new data point to all other training data points. So while working with KNN, we would be dividing the data into training data into and test data, and we'll find out the equilibrium distance between them. And according to that, we would be find out the predictive modeling. And the distance can be of any type, that is equilibrium distance or Manhattan. And we would be finding out the k nearest data points, where k could be any integer. So let's try to understand what exactly K is, and then we'll talk about the pros and cons. And finally, we would be moving on to designing and implementing KNN algorithm in Python. The intuition behind KNN algorithm is the one of the simplest of all supervised machine learning, and it simply calculates the distance of a new data point to all other training data points. And as I mentioned, that it assigns the data point to the class to which the majority of k data points belongs. So let's see. Let's take suppose we have a data set with two variables. We have a data set with two variables. We define x into blue, or x into blue class or red class. This could be x, or this could be x, which would be in red class or blue class. And let's suppose we would like to find out that to which point it is nearer to this x is, we are adding a new point, we added a new point, and we wanted to find out this is which is the nearest point to this particular new variable. And this could be done by calculating the distance of point x from all the other points. And let's suppose if I set value of k is equal to 3. So in this case, the value of k is equal to 3. So we would be start looking, it would find out the three nearest point with least distance to this new point. So in this case, 1, 2, and these 3 points are nearer to this. And all these 3 points we have enclosed within a circle, number 1, number 2, number 3. And the final step after finding out the nearest coordinates, nearest points, the final step is to assign a new point to the class to which majority of the 3 nearest point belongs. And from this figure we can see that the 2 of the 3 nearest point belongs to class red. So our ultimate goal is to find out whether this new point we are adding, this belongs to a blue class or red class. And because this is near to the red, this is more near to red, so we can consider that this belongs to red class. And this we can find out by using KNN algorithm. So finally, the new data point will be classified as red class. So this can be figured out, or this can be configured by KNN algorithm. Now let's try to understand the pros and cons. The pros are that it is extremely easy to implement, and it is much faster than other algorithm that requires training. Example, linear regression and so on. The only two parameters required to implement KNN, that is a value of k and the distance function. Distance could be find out using Euclidean distance or Manhattan distance. And what are cons? That it is not suitable for large data set. It is not suitable for huge data set with high dimensional data, because with large number of dimensions it becomes difficult for algorithm to calculate the distance in each dimension. And it's a the cost also gets increases, so it's a high prediction cost for large data set. And it doesn't work well with the categorical features. It is difficult to find out the distance between dimensions with categorical features. So these are the pros and cons of KNN algorithm. Let's try to implement the KNN algorithm on our financial data set. And I would like to see, or basically I would like to predict the upcoming results. So I would be going to apply the KNN algorithm on revenue, cost of revenue, gross profit, and product category. So first of all, let's look at the data set. Let's look at the data set. Although it is not favorable with the long structure data set, but just for a demonstration, I am taking it. So that's the data set. So let's start working on. So first of all, we need to import libraries. So I import numpy as np, import pandas as pd, and we would be using scikit-learn for implementing KNN. So we'll be using import sklearn dot model underscore selection train underscore test underscore split. So that's a library which will be used to implement, which will be used to create the training data and the test data, or to divide the data into two data sets, training data and test data, and then implement functionality. sklearn dot pre processing standard scalar from sklearn dot. This is to find out the nearest points, neighbors, and this can be find out by using k neighbors classifiers. K neighbors classifier from sklearn dot matrix. So I would suggest you to install the scikit-learn in your environment, because it would be used in various machine learning concepts. And also we can implement a library to find out the accuracy store. sklearn dot matrix import accuracy underscore score. So let me test this, and if any error exists, knn 4. So now no errors, and it will execute and it will load and add reference to all the classes. Now in next step, we would be going to load financial data into Python in using pandas, and then we would be dividing into two data sets, the X data and Y data, or training data and test data. So the next step is to load data. So I write data set is equal to pd dot read underscore csv and dataset name, and my dataset is finance data 1.csv, finance data 1.csv, finance data 1.csv, and I'm extracting only the required columns, because in dataset, if I write dataset dot head, all right, print dataset dot head. So it is showing 5 rows. Head is used to print only top 5 records. 23 columns are there, but I want only I require only product category, gross profit, revenue, and cost of revenue. So I'll extract the data from dataset and store into dataset 2. So I write dataset 2 is equal to dataset, and I would be extracting revenue, comma, cost of revenue, comma, gross profit, product underscore category. And I would be printing data set 2 dot head, sorry, data set 2 dot head 100. So this would be printing top 100 records, including 5 columns. Gross underscore profit, P is small. Be very careful about the headings and all, because it's a case sensitive language. And cost of revenue, R is also small. So sorry about the errors. So these all are syntactical errors. So you can see we got the data for three, or sorry, for four, 1, 2, 3, and 4 columns: revenue, cost of revenue, gross profit, and product category. Now our job is to implement the predictive data based on using KNN algorithm, and by implementing the test data and the training data. So very first I would be finding out the X, and in X we would be storing all the category, means we would be storing all the numeric data. So I write X is equal to data set 2 dot I location -1 dot values, and Y is equal to data set 2 dot I location 3 dot values. And now if we print X, let's see what X is returning to us. So X is only giving us the numerical data, and if I only print Y would be reverting only labels. Y is returning only labels to us now. So we got X and Y, and now we are going to pass it to find out the test data and the training data. So we would be dividing into text training and text, and we would be specifying what's the percentage we would be include into test and training. So here I write x underscore train comma x underscore test comma y underscore train comma y underscore test is equal to, we would be using train underscore test underscore split functionality, and we pass x comma y comma test, and when I write size is equal to 0.20, so it means that 20% will be 20% of data is into test and 80% is into training. So we can increase the size, we can change it to 70 30 70 as it for training, 30 for test. Here it is 80 for training and 20 for test. Scalar is equal to standard scalar dot fit x underscore training data, and I would be executing or step by step. So test is not defined, and if saying the test is not defined here, it should be test underscore size, and we have x underscore train. Now we would be transforming the training data and test data and store back into x underscore train. If we simple print training data, I just write print x underscore train, and I wanted to see what kind of data it holds. So you can see that's the training data in x training, and x underscore test data. So that's the test data for testing purpose. So 20% is into test and 80% is into training. In same manner, we have 20% of y data into training data, and 20% in as a 80% as a training data and 20% as a test labels. So we have this, and we used to classify this. I write x underscore train is equal to scalar dot transform x underscore training. So I did same for x training and x test, and finally we wanted to find out the three nearest data points. So we write classifiers, classifier, or it could be anything, you can give any name. So classifier is equal to k neighbors, k neighbors classifier. So we use k neighbors classifier, and number of neighbors, so we are predicting it based on three nearest data points. Neighbors is equal to 3, and we would be fitting classifier dot fit x underscore training data and y underscore training data. Neighbors. So just to find out the syntactical error, I am executing on every step. Now, next, I want to find out their accuracy. And in order to do that, to find out the training and test data accuracy, accuracy underscore training is equal to accuracy underscore score training comma classifier dot predict x underscore train, and same we would be predicting on test data, so that this would be the training data and that would be the test data based on y underscore x underscore test, and we would be predicting, so y underscore predict is equal to classifier dot predict x underscore test, and I would be printing the accuracy training data and accuracy test data, so we would be printing for both. So print train data accuracy underscore training data, and we would be printing test data accuracy, and this will help us that if we run the test, what's the accuracy for both for training data as well as for test data, and let's print it. So this is the final output. We have training data accuracy and test data accuracy. So it means whenever we perform a test, it almost about 40% the test will satisfy, and so the test will be satisfied, it will clear the test in more than 40%, and that's the training data accuracy. And I want to print the prediction. So we have prediction in y prediction, print y underscore prediction, with prediction. I would be printing the confusion matrix and the classification reports both for y test and y prediction, and y test and y prediction both for confusion matrix and classification reports, along with the training data accuracy and test data accuracy. So when we execute this, we would be getting four outputs. So first of all, this is the confusion matrix for y prediction, y test and y prediction. This is the classification reports, that's the classification reports which would be showing the y test and y prediction. And here you see we have four uh, categories, four product categories: computers and mobile accessories, and its precision is 0.48, computers is 0.21, home appliances 0.61, mobile is 0.04, and that's the average out of total, and that's the support. And this is the training data accuracy and test data accuracy. And the final outcome for this solution is that the data set which we are using, if we perform a test data accuracy, we would be getting almost 45% data, of 45% of data will be accurate every time whenever we perform a test. So that's how we can use KNN algorithm in real-time data sets. So that's all in this video. If you have some queries, you can come up with your questions in, you can come up with your questions. You can write your comments in comment box. Thanks for watching. Have a nice day. Goodbye.